Hi there. This is Mr. Sand, and I want to tell you the difference between graphing distance versus time and position versus time. I'm going to use a distance versus time graph to show you what the I'm sorry, I'm going to use the position versus time graph to show you what the distance versus time graph is going to be. So on the top here, we're going to have this is going to be position, and down below we're going to have distance. Okay. Now, remember, position is where you go in relation to the origin, where distance is how far you go. So position has both scale and magnitude. So it's a vector. Well, distance just has scale, so it's a scalar. So you can only go up with distance. Right. So let's see. Let's make sure that this is all right. So we got time down below, down here, and the same time right here. Let's just say that these are seconds. And let's say that distance is meters, and the same thing for position is meters. Okay, so let's make a little graph. Right. So let's say that we just start off from 0, 0 times 0 meters, and an object goes from 0 to 1 meter. And then let's say that it goes position-wise, it goes back to 0. Okay? And then let's say it goes, I don't know, let's say we go to 1 meter again, and then stay at that 1 meter for the 4 seconds. Now, for an object, this object right here, if we think about what it's actually doing in space, let's say that we have an origin here, and let's say it's just like a person, and this person is going away 1 meter, and then coming back to that 0, that start point, and then it's going back out to 1 meter, and then it's staying there. This person is then staying there. So that's what's happened during this time right here. So they've gone away, then they've come back, then they've gone away, and they've stayed there. So that's what's going on. Now, distance-wise, notice that I did move this person here, then back, then there again. So the distance-wise, the distance that they've covered is pretty far compared to the position that they've gone to. They've only gone out to 1 meter here. That's that 1 meter away, but they've covered a lot of distance. So from 0 to 1, this person has, that person has covered that 1 meter just like before. But then when that person comes back to the origin, they still go another meter. So the distance is still going up. They're still going a distance. Okay? Then from here to there, you can see from 2 seconds to 3 seconds, that person is traveling another meter. So they've gone 1 meter away again. They've gone back over here. So guess what? You have to show that in the distance. It's gone up again. And then they've stayed at 3 seconds. They stay at that 1 meter. So this person is staying at that 1 meter. Okay? So this shows you that even though the position goes backwards, the distance, you're still moving a distance. You're still going, you're covering some ground. So you're still going, you're still traveling a distance, and so you have to show that we're going positively. There is no negative distance. It's only positive. You only can go upwards here. You can have negative position. Like we could go backwards here for position, but the distance cannot go backwards. It's only a positive quantity. So even though that this person has, as on this position graph, they've gone away, then they've come back, and then they've gone away, and they've stayed there. Here, the distance, you have to show all the total sum of this red line that I've gone back and forth here. So that's the difference between position and distance. I hope it makes sense, and I hope it lets you answer your questions in your workbook. Okay.